Dear students, today I am going to discuss another example on round robin scheduling algorithms. For more, you can see my video series on the round robin scheduling algorithms, where you will be getting an idea, and this is another example related to it. Round robin scheduling algorithm is one of the important scheduling algorithm normally covered in almost all the university exams. Hence, I have put some 2 to 3 examples additional for the students to understand more in deep. This is a scheduling algorithm almost all close to the FCFS, first come first serve algorithms, and moreover it is a preemptive scheduling algorithms. The one of the important component over here is that in the question you will see that draw a Gantt chart and compute average waiting time and average turnaround time, and here it is written time quantum and 3 units. Time quantum means that once the processor starts, the processor cannot be compute beyond the given time. That means if the quantum time is given, say t second, so within that t second the entire process need to compute. Otherwise the particular process will be considered as a default one, considered as a faulty process. So that's why the process need to follow the order of a quantum time. But in the other preemptive case, we don't follow the time quantum mechanisms. Rather, we follow a time. We take a particular unit of time based on the other process. Why? Because if other process is having a lower 80 times, so automatically we have to consider this one under the scheme of a ready queue. Ready queue. And more about the ready queue, I have also explained in every examples. Now here, let us see how this particular problem is being addressed. Now, if you see the first process, P0. So P0 arrives as a first process because its arrival time is 0. That's why the first process is being put as 0. Now, it's the 0 is arrival. Now, how long it will compute? In the earlier differential scheduling algorithm, we used to take based on the other process, say +1 or a +2 like that. But here we have to consider based on the time quantum. So we will be considering +3. So the process P0 will be executed after 3 unit time. So this PT, instead of 5, it will be having a 3 units of time. So it is -3, so it becomes 2 here. Now, here one thing you have to see that in this particular scheduling, priority does not have any significance. So that's why this particular I have removed, deleted from there. Now the next process is considered as P1. The P1 is the because it's a round robin. So round robin in the sense means it will keep on rotating in this particular order. So P0, after that P1. So in the P1 is the burst time is 3. So 3 minus 3 is 0. So +3 I have to add. So here it becomes 6. After this, the next process is what? P2, because P2 has to be in a queue. So what is the burst time? 8. So we cannot process 8. So 8 minus 3 is 5. So we write +3. So it becomes 9. Now here, for your understanding, you see, when the P0 process was running, it needed 3 burst times, and within these 3 burst times, you have seen that from 0 to P3 process has arrived in a queue. So this is known as ready queue. Okay, so that is known as ready queue. Now here you have to see that when the after the process P2, the next process is P3. So P3 will run for how long? P3 will run for again 3 units of time. So 6 minus 3 is 3 plus 3 we will add here. Here when we subtract, here we have to add. So it is 9 plus 3 is 12. After this, what is the next process? You will see that the process P1 is almost all over, so it is 0. So this is cancelled. Now the next process is what? P2, P0. So the P0 we will be considering, and how long? It is 2 units. Quantum time is 3. It should be either less than 3 or equal to 3. Within this 3 unit time, the process has to go. So we will consider the entire 2. So 2 becomes 0. So we write here the process P0, and then we will write here plus 2, it becomes 14. What is the next process? So this process also over. Next process is P2. So we will consider P2 here, and we will consider the process minus 3. So it becomes 2 here. So plus 3, it becomes 17 here. So after P2, which is the next process? P3. So in the P3 is what is that? We will be similarly considering minus 3. So it becomes 0. Plus 3, it becomes 20. After this one, which is the process? It is the process P2. It becomes 0. So process P2 becomes, we will be adding plus 2. So it becomes 22. It becomes 22. So we have seen this particular scenario is that you have seen that in this particular scenario is that P2 has repeated for how many times? One time from here to here, 1, 2 and 3. So one time here, 2 times here, and 3 times here. So here we are having 3 plus 3 6 and plus 2, and it becomes 22. So now what is the remaining task? Now we have to find the CT. Now how we will find the CT? CT is based on the how we are viewing from this particular case. Now here in this particular scenario, you will see that which is P2. P2 is how much? P2 is equal to, it is viewing from here. So P2 is equal to 22. So let me put it in this way. P2 is 22, the completion time. Because P2 is the, P2 may be repeating here P2, 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 but this P2 completes at 22. Then this is over. The next is P3. P3 is how much? The completion times. The completion time of P3 is equal to 20. Then after before P3 is what? P2. P2 is we have this P2 we have already considered from here. So then before P2 is P0. P0 is how much? It is 14. So we put it here. Now what is remaining? P1. So we see P1. P1 is here. So here it is 6. So we have got all the completion time. Now what is time arrival times? Turnaround time is a CT minus 80. So CT is how much? 14 minus 0 is 14. 6 minus 1 is 5. 22 minus 2, 20. 20 minus 3, 70. So this is the turnaround. Waiting time is turnaround time minus burst time. So 14 minus 5 is 9. 5 minus 3, 2. 20 minus 8, 12. 17 minus 6, 11. So now what is the remaining? Now we have to calculate the average turnaround time. Average turnaround time is total turnaround times divided by number of processes. Now that is equal to 14 plus 5 plus 20 plus 17 divided by 4. So this will give you around 14. Average waiting time is equal to total waiting time divided by number of processes. So that is equal to 9 plus 2 plus 12 plus 11 divided by 4. So that will give around 8.5. So this solves the problem related to the round robin scheduling algorithms. You practice this type of examples and be confident. Thank you.